Day 14 of 90, and today TypeScript stops being a thing you annotate and starts being a thing that protects you. Picture a typed API cache in production. Someone stores the wrong response shape, and 3 hours later your app crashes deserializing garbage. What if the container itself refused to let that happen? Today we build 4 generic data structures from scratch: a stack, a queue, an LRU cache, and a priority queue, and each one teaches the compiler to track your types through every push, pop, and eviction. We start with the stack, because it introduces the one symbol everything else depends on, t. Write class stack t, private items, t equals push item, t this.items.push item, pop t undefined, return this.items.pop. That t is not decoration. Create a stack string, try to push 42, and the compiler stops you cold before the code ever runs. Compare that to any, where the number slides right in and blows up later. The takeaway: type parameters are invariants, not labels. Now the queue, where we meet subtyping. Back it with 2 stacks for amortized O1 to queue, then derive class bounded qt extends qt that takes a capacity number. Notice extends qt carries the generic parameter straight through the subclass. A bounded queue is still a queue string. You'd reach for this in a job runner that caps pending work. And extends here is inheritance, keep it separate from the extends we're about to use for constraints. The LRU cache is where constraints earn their keep. Declare class LRU cache k extends string number v, backed by a map k, v plus a doubly linked list for O1 eviction. That k extends string number is a contract. It propagates into get key kv undefined and set key k value v. Try to use an object as a key and the compiler refuses, because in plain JavaScript object keys silently stringify to object and collide. Wire k to a URL string and v to a typed API response, and you've got a React query cache that can't store the wrong shape. Last structure, the priority queue, and the best inference trick of the day. Build a binary heap whose comparator is typed a, t, b, t equals number. Now watch, new priority queue, a, task, b, task, equals a dot priority, b dot priority. You never wrote the type argument. TypeScript infers t equals task from the comparator alone. Flip the comparator signature by accident and the error shows up at the type level, in your editor, not at 2 a.m. in a scheduler. The comparator isn't just logic, it's the thing teaching the compiler what t is. One more move that ties it together, making these compose. Implement symbol.iterator, iterable iterator t on your stack and suddenly spread, for of, and array. From all work with 0 type assertions. Need a read-only view for SDK consumers? Read-only stack t derives it for you. Want to add a method without subclassing? Intersection types, function peekable t, s, stack t and peek t undefined. The container stays generic the whole way down. Step back and every structure says the same thing. The stack proves t is an invariant. The queue carried it through subtyping. The LRU cache used extends to enforce a key contract. The priority queue inferred t from a callback. Type parameters are contracts, and contracts are what make refactoring safe instead of terrifying. Day 14 done. Build all 4 yourself today. Typing them once teaches you more than reading them 10 times. Subscribe for day 15.